Hey everyone, it is Thursday, July 26th, and this is what number am I up to? 6? Yeah, I really should start keeping track of these. I think this is the 6th of these, 5th of these videos, 5th. And how's everyone doing? Note to self, don't put my hands down on my desk like that. You'll notice that I got some feedback that light behind me was incredibly bright and hard to look at, so I turned on the mood lighting. Hope you like it. We can get nice and intimate over code. Oh yeah. Oh yeah. But today, we're going to be looking at functions. Let's see, do I have any other announcements before we start? No, not really. So, functions. Functions are, I would say they are the first fundamental block of programming. They are not a, they're not their own unique thing, I guess. Well, they are, but they aren't code you execute. A function is a way to group code and handle input and output. All the code you will ever write is going to be in a function of some kind. Whether you know it or not, all the code you do is inside a function. So we're back here in Eclipse. We're back in Java. And I'm gonna give you the basics, kind of what you do with a function. I'll give those to you today, and then we'll kind of go more in depth on functions next Tuesday. We'll kind of get into kind of a proper way to use functions and some of the more powerful things they can do. But to start, you just need to know what they are, right? So you'll remember back when we did Hello World, way back when, that I just told you to write this. I told you to write public class demo and then write out public static void main string brackets args. I told you to not worry about what it meant. Well, today we're going to find out what it meant, which is really awesome, actually. We're going to pause. I'll tell you what it is, I promise. But what we talked about yesterday, just talking about using if statements, loops, variables, input, output, those 5 things, it's really 3, because input and output are variables, but they're kind of special, so 5. I was there. I kind of worked on that level for like 4 years when I first started programming way back when, and this drove me nuts, because when I work in Java, it's just, well, you just write this out and then it's just kind of how it works, but I never knew why. Here's why. A function is a block of code, just like we have right here. It's a block set off by braces. Sometimes they're written like this. Sometimes you'll see them like that. Java, the preferred standard is like this. When you're working in C, C++, C#, all those languages, it'll look more like that. But it's set off by braces, and all it is just it's a block of code. Its name is going to be the last thing before these parentheses. In this case, it's main. In Java, the main method is called the main method. It's yay repetitive naming, but it's good because it means it does exactly what it says. The main method is the entry point. It's where the program will start looking for commands to execute when you first start any program. So the basic structure of a method or a function. Methods and functions in this case are the same thing. Those words are interchangeable. A function can be something else in other languages, but for Java, for right now, a function and a method are the same thing. I'll use the words interchangeably, and I just don't want you to get confused. They're the same thing. So the format, I'm going to put up in here a comma, is scope, modifiers, return type, name braces, and inside the braces, inputs, and then more braces. That's the structure of a function. And once again, with defining the terms, there are a few things you should just know what they are. Public here as a keyword is going to mean that my phone is almost dead, so I'll have no idea how long I'm recording for. So if I talk for an hour, you get to learn more. Anyway, a public function is going to be a function that can be seen, quote unquote. It's not literally seen, but can be accessed by other pieces of code. The alternative is or specifically another class, but I'm not going to go into what class definitions are right now. So that's a whole different larger scope. But just so you know, for right now, start all of your methods with public. Just the other option is private, which means only things within that class can access it. Just so you know. So you start with a scope, and then you have modifiers. Modifiers are things like static. Final is another modifier. Let's see. In Java, abstract, I think are the three. There might be others that I'm forgetting, but if so, you don't use them very often because I'd be thinking of them. One second, let me just check this. Yeah, okay, I want to make sure everything's working properly. Okay, so you'll have the modifiers there. Static is going to mean that it's not an instantiated thing. Those are all definitions that you have to have when you start working in classes. Right now, just put public and static on the front of things. It'll make your life easier as you start to go into functions, and we'll explore when you need those and when you don't later. But that's what they are. They're definitions on scoping of classes and rigidity and that kind of thing. Return type, though, is important. Return type you need to know on a function. You need to know. It's one of the three things that's important in a function. Void means it doesn't return anything. If I do return hello world here, it's going to yell at me. See? It says void methods cannot return a value. So can't return stuff with void. And that makes sense for the main execution one because it's going to start executing here. You're going to do stuff, even more stuff. You're going to keep going, and then once it's done, it's just going to exit. It's the end of the program. So of course it doesn't return anything. In some other languages, that's not true. The main method will return 0, meaning everything worked properly. Older style languages will do that, especially C. That's a important C thing to make sure everything runs properly. And in Java, you can do that, but it's not required. The program just assumes, oh, you exited properly, you're good. Other return types, though, a return type can be anything. It can be anything that's a piece of data. So I can have a method that says public static int add, and then I need some inputs. Up here we have a string array called args, which is just going to be whatever arguments. So if you opened up your terminal and ran this in the command line, the stuff after the name of it, so you'd go Java demo, and then if you wanted to put in arguments, that's where those would go. Those would go in as the inputs to that method. Just so you know what public static void main is, because it bothered me for a long time not knowing. But the more relevant example you're going to want to think about it. Let's say I have int first. Let's see, what's a good? Oh shit, what are they called? When you add two things together, they're called I don't know, whatever. Additives, adders, I don't know. Just we'll call it first int and second int, which are not good variable names. but for the purposes of the demo, it doesn't terribly matter. Yeah. So you'll notice here, I have int here defined as the return type, and over here it's yelling at me because this method must return a result of type int, and I'm not right now. There's nothing in it. So let's say I wanted to just add these numbers together. Well, then I would return first int plus second int, and always have your semicolon. I don't think I've mentioned this yet, but semicolons are important. And on any line of code that doesn't have a brace, you need a semicolon. A semicolon marks the end of a line. I didn't mention that. It's one of those habitual things I forgot that, you wouldn't know that, right, if you've never worked in Java, but you should make sure you always include the semicolon. So in here, if I wanted to do int a equals 5, int b equals 3, and then I can do system out println add a and b. And system out println is another function. It's specifically a library function. The println is the actual name of the function, and then system and out are going to be well, they're packages, but let's just call them folders for now, that the function is put in inside a library. And a library is just a file or a set of files that have lots of functions for you to use. Your Java, the language, is built on libraries. There's except for the syntax, there's no functional difference between the language and the libraries. They're meshed together. That was actually brought up in the court case. If you followed that earlier with Google v. Oracle, when they were talking about the Dalvik operating system, Dalvik, I think, operating system on Android, Oracle was saying that they owned the API and all that stuff. We won't go there, but one of the rulings the court made was that the language and the library are too intermeshed to say that they're disparate. Anyway, random sidebar. But let's say, I'm trying to think of a more interesting example. Let's say that I wanted to, I guess I could pull up some of my code, actually, so I'm not having to think of an example. 1 second, let me pull up some code. Some stuff from, is this any good? Sorry, hold on 1 second. Nope. I'm looking through old code and seeing what I can find. Okay, yeah, this works. This is an old assignment. So here, can you see? Yeah, you can see. Okay. I'm back over in Notepad++, just because I pulled this up real quickly. Okay, so here we have this bank account thing. You notice this is commented all to hell. And ignore, that doesn't really matter. But okay, so you have a withdrawal function here. Let's just take a look at this as an example. Public, once again, so other people can access. Boolean. A Boolean function is going to be just a true or false. In this case, since it's a withdrawal, you can pretty easily infer that success is going to be true and failure is going to be false. And success would be you've successfully withdrawn some money. It doesn't return how much money you have. It just tells you, yes, you withdrew some money. Congratulations. And then you have a double here. A double, you'll remember, is a long floating point number, which means it can have decimals. It's named amount. And then, okay, so then we have an if statement where it says if your balance, which we defined up here as private double balance, let's just define the variable up there. Where are we? Okay. If balance is greater than amount, which is your amount you're withdrawing, and amount is greater than 0, so you can't withdraw a negative amount, then subtract the amount from the balance and return true. Otherwise, return false. So, I mean, you can just see what that does. It's if you have enough money in your account to withdraw the amount you want, and the amount you're withdrawing is positive, give it back to them and take it out of the balance. But that's not really the important part. That's kind of what we already looked at. The important bit is that what this function does, right, is I can withdraw money here. And then I have deposit other things. For example, you can have get balance. It's just going to return the amount of this variable. And you might ask, why would you do that? And this will kind of become more apparent as we get later and later into things, but it's better to control how variables get accessed than to just give people access to them. And that might not make sense because you're thinking, well, the user can't access them, they can't see the code, and I'm writing my code and I know how my variables work, so what's it matter? Well, hopefully, eventually, you're not going to just be writing your code. You're going to be writing, code with other people. You're going to be collaborating on something. And when you do that, they may not be familiar with your code. In fact, I can almost promise you they won't be. And so they may either make assumptions about how your variables get accessed, or they'll just not think about it. Which means they won't interact with your code well, and it'll break things. So what you do instead is you make your variables private. They can't access them directly, but then you give them a method that says get balance. Here, you can check the balance. You can't just straight access the variable and modify it and do all that. You have to go through withdrawal if you want to modify the balance, because there are things you can do that wouldn't make sense. You have to go through the deposit and that kind of thing. They're called getters and setters. They control access to variables. It's a very common use for functions. And all this toString, for example, will take the information in this class bank account. Again, don't worry what a class is, but it'll take it and it'll parse it out into a semicolon delimited string that is human readable. But why is this important or special? Because you can just think, well, just run the code, right? I said yesterday, actually, you can just copy all the code that's in the method, put it over in the in where you called the function, and it would work. Well, one, you can't always do that. I kind of lied to you. You can't always do that. And two, you don't want to, because then you have the same copy and pasted code in 10, 20, 100 places, depending on how big your code gets. And if you need to make a change into it, let's say you have a bug where you added something when you're supposed to subtract, and believe me, that is common. It's amazingly common when you're dealing with like moving coordinates and you forget, oh yeah, the coordinate grid on computers is actually flipped upside down, and you add to try to go up and actually you go down, that kind of thing, really common. If you need to go change that, what would you rather do? Have a function that's getting called and then just go change it right here so you add instead of subtract? Or would you rather go through 100 copy-pasted instances and have to go change it? It's so much easier to use the function. It also lets you assign blocks of code into groupings, which we'll get to later. That's more object-oriented things, which I'm big on. I think it's really important, but we're beyond this. Right now we're just looking at functions. So that's the structure of a function. It's kind of the beginning uses. But that's nowhere near all. So if I go back to the demo over here, return 0. It's just I don't want it red. It pains me to see, it doesn't like it, fix it. No, please. So anyway, let's say that you had some special math function you're doing. I don't know what. I don't know. Let's say you have some special math function, right? And you need to add, okay, well, let's just do this. Let's say you need to add 3 numbers rather than 2. That's reasonable, right? I need to add 3 sets of things all the time. Yeah, just return 0 again. But, okay, look at this. Now, I'm hoping you're observing and going, huh? How can you do that? They're named the same thing. If I go up here and call, add AB, how does it know which add to go to? There are 2 of them. Well, I'll probably notice, it's kind of obvious, that they have different inputs. The output, the name and the input of a method come together to be known as what's called the signature of that method. And the computer, or specifically the compiler, will be able to differentiate between those things. So for example, when I call add, parentheses a, comma b, parentheses, it knows go use the first one because there's only two inputs. If I then did add a, b, c, well, there is no c, so let's have c equals 9. If I go do that, it knows, okay, go down to this one. This is really important, and it's called method overloading. Method overloading lets you have methods with the same name but a different signature, and they're generally going to do the same thing or close to the same thing. That's why they're named the same, but with different kinds of inputs. This is really common when you're creating new objects, and we haven't gotten to objects yet, but that's, once again, okay. For example, Java has a thing called a scanner, which lets you loop through files easily. Scanner, or better yet, it accepts keyboard input. Standard keyboard equals new scanner system in. Okay, none of that's really important. You'll notice how I don't have scanner here. It's not a standard Java thing, so I have to import it. It's really simple. Just import Java util scanner. You're going to do that a lot. If you actually went and made the rock, paper, scissors game I told you to do, you probably had to import math. You probably had to learn how to go do that. And I specifically didn't tell you to go import it because I wanted you to figure out that's how you import things. Because that's just a little bit of Googling, but it's good to go figure out. But for example, scanner here takes in lots of different inputs. System in is a print stream. And you don't even know what that is. It's just a string of letters, but it doesn't really matter. A string of, I guess, bits, because you can put anything in a string. But that's not necessarily what it needs. I could also do new file, demo file, which doesn't exist, but don't worry about it. If I go import file here, ignore that. It's more stuff that doesn't matter. But the interesting bit here is the fact that I can call this new scanner, and this is it is a method. It's what's called the constructor of this object. I can call this method with two different inputs, and it won't care because it will know, oh, call this method, or oh, call that method, even though they're named the same thing because they're actually different. What you can't do is, or actually, hold on, let me tell you something else you can do. Let's say that you want to do this. Let's say for some reason you want to add a string and an integer. That doesn't make any sense. You try to do that, depending on the language you're in, you'll either get very strange numbers from it converting strings to ints and then trying to do the math, or it'll just tell you, no, you can't do that. But ignoring that, that's not really the point. The cool part here is the fact that it'll also differentiate based on the input type, not just the input name. So it can tell these are different because the first input is a string, and the second input is an int in here in the second add, and the first and second inputs over here are ints. So that's cool. That's more method overloading, and I kind of spend a lot of time talking about it just because it's interesting. You don't need overloading. There's nothing you can do with overloading that you can't do, well, nothing without object-oriented programming that you can do with overloading that you can't do without, but it's just good. It helps structure your code in a way that makes sense and is legible. But I really, hold on, I'm going to go find more interesting examples of using methods. Let me pull up, in one of my classes last year, I had to, oh shoot, no, I just closed it, crap. Sorry guys, hold on one second. I had slippery fingers there. I clicked the wrong thing. I made a green screen, which is a really cool project, by the way. Props to my professor who assigned it. We're back. Yeah. Okay. I always have to check that. I wish I had another monitor over here to be able to check that without you seeing it, but since I'm on a laptop, that's not really possible. But anyway, this is a green screen program we made. And this is the entire main method. Look at that. It's real simple. And it's really easy to understand, right? Check input. Well, that is exactly what it says. Validates user input and ends execution if it's invalid. So if the input is invalid, quit. And then you could have an else here to say else do this, but that's kind of encapsulated in the fact that it quits if it doesn't work, so you don't need the else. But logically, if the input isn't valid, quit. Else, you're going to save an image. Well, save what image? Okay, we're going to read an image, and then we have inputs. You'll notice this is the args. Input 1, input 2, and then a color, and then I believe these are the outputs. Actually, I should have commented this. This is something where you're using these args and it doesn't tell me what those are, and I don't remember going back and looking at this code a year later. I'm pretty sure those are like the output arguments. But you'll notice all of these are in functions, so it makes the flow of what's doing what very simple. It also lets me chain together certain things. Like, for example, this read image is going to read and process an image and hand me back one where I've overlaid the two into a green screen. And then that is actually grouped inside these parentheses. You'll notice they're there and there. And that gets passed into the save image function, which then goes and saves it. So it lets me pass around data like that because the output of one function can be the input of another, which makes them really powerful because I'm not having to store anything in variables. I'm not having to try to manipulate variables. I can just pass things directly from one method to another and process them while still keeping them evenly and understandably grouped. But let's scroll down just to check input, and you can just see what it does real quick. It's just more if statements, I'm pretty sure. It should be. Yeah, if, return. Important. If you don't have every possible flow of control in the method, you have to arrive at a return statement at some point, which means you can do if stuff return, else stuff return, or you can just do if stuff return and then another return. But you always have to end up at a return somewhere. You can't do like if stuff return, else do stuff, don't return. You need to return something, otherwise it goes, hey, wait a minute. I expected an output here, unless it's void, in which case you can't return anything there. So yeah, either have return statements so you always get there, or don't have them at all. But this is just parsing out the input. You'll notice like the to lowercase function on a string equals, and then that, because you can't actually compare strings directly. But that's a later thing. But this is more comparisons. You'll notice my GitHub hashing there. Very cool. But anyway, so all that code down there to validate that just sits up here. And what it lets me do is, if any of these happen to be true, I can return true. Otherwise, I return false. Notice at the very end, it just goes through all the ifs and ifs, and if all this executes and nothing happens, well, then it just returns false, meaning it was valid input. It's kind of reversed. If it's valid input, it returns false, because it's actually checking if it's invalid input. Anyway, but it lets me pass that into a very simple if, which then lets me print it out. If I didn't want to do it that way with the method, if I wanted to just do it with straight if-else, I mean, it's doable. What I would have to do is set a Boolean variable, and then set that variable every place I'd have a return statement, and then just execute this code. And it would do the same thing, and I would check that return variable, but that variable I don't actually need to store its value for any reason. I only need it to be able to check this if statement. So there's no reason to actually assign it to your memory. So you don't. You just put it in a method and then put the method inside the if block, because that method returns a true or a false statement, which is what an if block wants. All Boolean logic returns a true or a false, so it's the same thing. It just so happens that, what was I saying? Just brain falls off like that. Isn't that wonderful? Where you just, it's like, well, there were thoughts there. They were real pretty, and then they're just gone. Anyway, it allows you to do that. It's important when you have large applications where you're like doing things hundreds of thousands of times, and I promise you you'll do things hundreds of thousands of times, to not be setting variables over and over and over and over, because you'll use up your user's RAM like crazy. You'll just eat into the memory, and it'll cause problems. You know, memory leaks, you slow everything down. Anyway, so we pass in these functions to each other, and then it lets us kind of group all this code. For example, save image here is pretty simple. It creates a file, and we won't worry about how it does that because you don't know what objects are, but it creates a file, it writes it out, it prints it, and then it's done. It's a void, you'll notice it doesn't return anything. Save image isn't being assigned everything here, it just executes. So it goes, accept input. That input, you'll notice this right here, all of this that's inside the parentheses, is going to get passed into these three inputs: the buffered image input, string file name, string file type. Notice the commas here are setting that off. Or actually, sorry about that. It's these commas because this all right here is the first input, that's the second input, and that's the third input. So you see how that works. And then things like this, where it does all this logic to figure out what kind of color you need, right? It's figuring out what color the background of the image is, so it can turn into a green screen. So it could technically also be a blue screen or a red screen or whatever the heck screen color you want. So that does all this logic and figures that out. If I didn't want to do that, I'm actually not sure how I would pass it into anything else, because figuring that out would be so convoluted. It'd be so many variables that the logic would just kind of swim in your head, which is what makes methods so great, is you can pass information around like that. So yeah, the real bulk of this program, where is it? Oh, wait, I just realized there are like two of this file. Public class, green screen. Public, okay, there are two of them. I don't know why there are two. That's weird. Anyway, it doesn't matter though. The primary execution block, where like all the work gets done, even though main does all the stuff, and this is where you start, and this is where you end, and I just say system exit. That's what I was talking about, is it returns that 0. Just even though it doesn't return anything, it exits with a 0. And you used to just do that by having this be an integer return and returning it. But they just changed the syntax in Java. It's the same thing. But you'll notice most of the work is getting done here in read image. And you'll notice, for example, just to harp on my last point, assignment statements, loops, assignment statements, if statement, a set function, which is just setting another variable, so it's still an assignment statement, it's an assignment function. Haha. Look at that, that's all it's doing. So anyway, that's my introduction to functions. Why functions are cool and what you can do with them. Functional programming is big. I mean, it was all, we sent the man, we put a man on the moon using functional programming. Entirely serious. So you can sit here and do a lot with this. You can do a lot with it. Now that you know how to do that, you have all the tools you need to go start exploring libraries, and you can realize that you can call these functions and they'll do all this really cool stuff behind the scenes. So that's my introduction to functions. We'll do more with them on Tuesday. Oh yeah, the second or the third video, for some reason YouTube really doesn't like it, so I'm going to keep working on it and trying to get it uploaded. If I can't get it done tonight, I'll just re-record it and put it up, and you can go back and watch that. But yeah, that's all I have for you. See you next time. Let me see if I can end this properly.